Can you be very explicit about how the jumping looked like?
So actually imagine my finger like the leg. So we ask the participant to perform countermovement jump for the first jump, while upon the landing, the participant perform a drop jump. Let's say jump as quick as you can while you're landing from your first jump. So essentially it's like jump, rebound, and landing. Okay.
Welcome, Jason, to Evidence Strong Show. It's my pleasure to have you. Please briefly introduce yourself.
Thank you very much for inviting me. So just to call me Jason, I'm currently doing my PhD at London Sports Institute at Middlesex University, supervised by Dr. Chris Bishop and Professor Anthony Turner. So just to quickly introduce my PhD, it's all about evaluating new jump protocol called Countermovement Rebound Jump. So essentially during this new protocol, the participants complete the counter-movement jump followed by a rapid rebound jump. So the reason we developing this new protocol is because, for example, the fast and slow SSA function is quite important in this day and age for almost every sport, right? And if we do a drop jump testing, it's very difficult to standardize the drop jump height. And if the drop jump height is slightly changed, it may be affected the subsequent analysis of the drop jump performance. And also, if we do multiple jump testings, which kind of fatigue the participant very quickly. So we was wondering, can we develop a new protocol to simultaneously evaluate the fast and the slow SSA functions? So in my PhD, we started by analysis the reliability of every matrix we can collect it from the countermovement rebound jump, followed by some investigations to say if there is correlation between the countermovement rebound jump matrix and independent measure of the athletic performance, like sprinting, change of direction, isometric mid-cycle strength, and also we have used some queuing effects, which we'll be discussing today, to see if we can use some strategy to manually manipulate those kind of CA margin matrix, and ending this story by investigating the sensitivity of the CA margin matrix under the fatigue condition.
Awesome. So the paper we are talking about today is effect of external verbal cueing on counter movement rebound jump performance. So why this study?
It started by why we are going to evaluate the jump testing, why the jump testing is become ever increasingly popular in the stress and conditioning field. Because, for example, the jump testing like the drop jump, counter movement jump, and squat jump is very popular. It's like our go-to for tracking the athlete's explosive power, reactive strength, or maximum strength, which all these qualities are crucial in sports, which requires quickly, powerful movements, make all the differences, like the basketball, the rugby, the sprinting, even the weightlifting, right? And by measuring how high and how fast our athletes can jump, we can get something like a snapshot of their lower limb, lower body strength, or how well our athlete's central nervous system is firing. It's not just about seeing the progress, it's also a way to spot their potential weaknesses or imbalance of the body, like the asymmetry, right? Always considering how the asymmetry happens in your lower limb strengths or jump strategies could help the practitioners to decide if there are any potential risk of injuries down the line. And in practical, the results from the jump testing also help us to fine-tune the training programs and ensuring our athletes is working towards improving their performance, not to decrease their performance, while staying the injury-free, right? Because we have known that some jump matrix, like we commonly measured RSI, reactive strength index, or even the RSM mode, are linking to some independent measure of the performance, like sprinting speed, change of direction speed. Assuming we are measuring these jump performance and they are linking to the athletic performance, so we don't actually need to measure them in the real practical field. For example, we don't have enough time to do the real sprinting speed testing because we need a track. We also need some equipment to set up the testing scenario, which may not be very clever move if we are going to have a training session or the competition session, is that we can using the jump test as a time efficient or user-friendly tool to evaluate this performance. And also the practitioners could take the commonly utilized portable force plate to the field, to the training room to conduct a daily and weekly training evaluation. So that's why we think performing a jump testing as daily or weekly monitoring tool is clever, is most more useful compared to really evaluating some other performance.
Yeah, that's true. That saves time and
Right.
seems to be the go-to technique recently, at least for strength and conditioning coaches, but also in weightlifting. It made its way to weightlifting. So lots of new possibilities are opening. All right. How did you go about designing your study? What was the research question and then how you set up the study?
So the research question would be how the different cueing conditions affect countermovement rebound jump matrix. So we actually recruited 21 participants from our MSc strength and conditioning program, and they are required to regularly engaging in the field-based team sports and also engaging in the plyometric and strength training, because they can set up a minimum level to guarantee they can perform the countermovement rebound jump using correct technique and consistent strategies. So because we would like to know how participants have changed their jump strategy between the cueing conditions, so we utilized the full split system to measure some strategy-based matrix like the jump height, RSI, etc. We also incorporated the 3D mocap system to have an overall evaluation of the strategy-based matrix, also the kinetic matrix, including the joint work as well as the individual contribution to the total positive work and the negative work. So the positive work indicating the joint work generated during the propulsive phase, which will directly affect the jump performance, as well as during the braking phases, which kind of like how to evaluate how efficiently the athletes are utilizing the SSA function. So we always ask them to avoid the arm swing during all the jump types, and we set up 3 different cueing conditions. The first one being the height focused condition, which we cued them to reach for the ceiling, jump as high as you can for both jumps of the CMRG, and this cueing condition aiming to maximize the jump height or vertical displacement only without considering any time spending on the ground. And in the second condition, we asked them to focusing on the quicknesses, which they was cued to get off the ground and jump as fast as you can for both jumps, where the emphasis changed which placed on minimizing the time to take off for the first jump, as well as the ground contact time between the first and the second jump. So we also in the final condition, because we need to set up something like general the cue or the combined cue to try to maximize their countermovement rebound jump performance, we cued them to reach for the ceiling, jump as high as you can for both jumps, and while still spending little amount of time on the ground for both jumps. So we aimed using this combined cue to maximize their RSI and RSI mode concurrently. Yeah, this is a general setup or methodology of our study.
That's very good. Jason, could I ask you to not use the abbreviations, because it would be very hard for people to follow, especially because the conditions are so similar. So the first one, focusing on the height, jump as high as you can to the ceiling. The second, spend as little time as possible on the ground, so jump as fast as you can. And the third one was do both, so as fast as you can off the ground, but also as high as you can.
Yes.
Now,
so
before we move on, can you be very explicit about how the jumping looked like?
So actually, imagine my finger like the leg. So we asked the participant to perform countermovement jump for the first jump, while upon the landing, the participant perform a drop jump, let's say jump as quick as you can while you're landing from your first jump. So essentially it's like jump, rebound, and landing. So the first jump aimed to maximize their slow stretch-shortening cycle function, while the second jump aiming to maximize the fast stretch-shortening cycle function.
That's awesome. Okay, so we know there were 3 groups focusing on different qualities of the jump, and the jumping was counter-movement jump with the rebound connected together.
Yeah.
All right. Are we ready for the results?
Yeah, of course.
Awesome. So you had 3 groups. What have you found?
So let's reiterate what we used for our methodology: the jump height focused condition, the jump velocity focused condition, and combined focused condition. So we found if we use height and the velocity-based condition, they significantly decrease or increase our measured matrix, resulting in, let's say, somewhat polarizing the jump strategy. For example, if we're using the height-focused condition, they significantly increase the 2 jump heights during the countermovement rebound jump, and also the positive hip joint works. However, these also come with a cost, because we asked them to maximize their jump height without considering any times, and this especially increase increase the ground contact time and the time to take off, which also decrease the leg stiffnesses. Essentially, when the athletes aim to jump as high as they can, they had to spending longer time on the ground and compromise their leg stiffness because they want to put in more force on the ground to generate a large impulses. On the other hand, if we cued them to utilize the velocity-based cue, the result was quite different. The focus on the quicknesses lead to significantly reduce the vertical displacement, which is the jump height, because they utilize the somewhat like a shallower counter-movement depths, because they don't dig that much when you ask for quickness. They just want to get on the ground as quick as you can, which inevitably reduces the joint work from the hip and the knee joint as well. However, this emphasis on the speed came at the expenses on the jump height in both jump of the CMRG. The reason for this trade-off is when they prioritize the quicknesses, they don't have enough time to generate the impulse, similar to the height focused cue, but in a different way. Interestingly, when it comes to the combined cue, we ask them to maximize the jump height while they didn't increase the time on the ground. They kind of gave us balanced strategy between the height and the quicknesses, because we think this is the most favorable outcomes. The reactive strength index and the reactive strength index modified was the highest amongst all the conditions. These suggest this is a very positive outcome, although the statistical significance was not achieved. But we talked before, this may be because our sample size or selected matrix matter, but this just suggested that our athletes are promoted with them by the cue. They find mid-ground, they shorten their ground contact time compared to the height-focused cue, while they maintain the jump height, and they manage to increase their jump height while they're trying to get a closer ground contact time with velocity-based cue. So essentially giving us a more balanced and effective jump strategy. Yeah, this is kind of overall finding from our study.
So it is possible to, with your cueing, to force athletes to perform as you wish. So if you want them to as high as they can, you can use it. You can cue them to do that. If you want them to rebound as quickly as possible, you can cue that, and then they will execute it. If you want both, you have to cue both. Otherwise, they will optimize for something else, either for height or for weakness or fast rebound. So very, very interesting finding.
Yeah, exactly. So this is what we want to deliver to the audience is, if you want your jump testing, no matter what kind of jump protocol, counter-movement jump, drop jump, squat jump, or even you use the counter-movement rebound jump from our study, you definitely need to provide your athletes or participants a very, very clear understanding about what they're going to do, and using some kind of external verbal cues can better affect their performance.
So now in terms of the comparison within the group, are you able to distinguish between the athletes? Because you mentioned fast shortening cycle and slow shortening cycle. Are you able to see the difference between the athletes, and are you able to diagnose this athlete needs more training in this area versus the other?
Yeah, exactly. So let's say, take an example. If we utilized two different cues, let's say height-focused cue and the velocity-based cue, from their data, we should say, okay, their data leaning towards the maximum the jump height during the height-focused cue, while they should leaning towards reducing the ground contact time during the velocity-based cue. However, we conducted an individual analysis for every participant, and we found some participants maintain their jump height and maintain their ground contact time under three conditions. This kind of gave us, let's say, a really terrible data because they didn't understand. No offense, thanks to my participant, of course. They gave us an understanding they don't change their jump strategy that much, and we probably need to evaluate their force time curve in that matter, because we want to know why they don't change. Maybe they don't have that capability to generating that big magnitude of force under the height-focused condition, while they might don't know how to quickly react on the ground because their leg stiffness is not that high enough. They need some kind of like the bounce training to learn how to reacting, how to pre-creating the tension before contact with the ground. I think that kind of information definitely gave us some clues for the training program design. And the decision of using different cues will be highly impacted by the aim of the assessment, I would say. For example, when we do something like the strength training for a period for either main training and training A, we probably ask the participant to utilize the height-focused cue instead of using velocity or combined cue, because we want to know whether these athletes has improved their lower limb strength throughout the training period. Instead, if we have utilized a parametric protocol to trying to improve the time to spending on the ground, to maximize the sprinting performance, which really need the shortest time on the ground, as well as inserting high amount of force on the ground, we probably utilize combined cue because we want to know they can better insert the high amount of force while didn't extending the time spending on the ground. I think definitely the utilized of the cue is depending on the aim of the evaluation.
Excellent. I think we're ready for the take-home message.
Right, okay. We do have a couple take-home messages for coaches and athletes, as well as all kinds of practitioners. One of the key findings from a study is how body adapted depending on whether the goal is quicknesses of the height. So when athletes aim to get off the ground as quickly as they can, they rely heavily onto their ankle joint. This means the distal joint, like the ankle, takes the majority of the load, allowing for a very rapid push-off and contact with the ground. On the other hand, when the focus is achieving the maximum jump height or vertical displacement for both jump, the contribution will shift it from the distal to the proximal body to the proximal joints, particularly the hip followed by the knee, and which the hip joint will become the primary driver of the total power and force. And this insight is very crucial for the coaches to designing their drills that targeted the training intervention or the assessment performance outcomes. And regarding the jump strategy changes between the condition, we are going to discuss that by separated the condition. So how to utilize that, I think definitely the audience want to know. Okay, you're discussing how the changes in the jump strategy, now how I could utilize them in my own practice. So let's say if you are going to looking at or assess the improvement in the jump height after a training program, let's say the strength training program or the weightlifting program of their lower limbs, use height-focused cue is very effective, because in this cueing condition, the athletes will tend to adopt a double counter movement strategy. Under this condition, you can obviously say they dip a lot to a bigger magnitude and both jump types, and also characterized by longer ground contact time and a deeper counter movement depth. This strategy will help you to maximize the propulsive force and impulse, allowing for a big magnitude of the jump height. Additionally, importantly, because these cues doesn't significantly increase or ramp up the intensity of the jump type of the jump testing, it is very, very suitable for athletes in the later stage of the rehab phases when they're not very ready for transitioning back to the full intensity training or testing, but aren't ready for the maximum loading yet. So utilize the height-focused cue can somewhat increasing your testing or training intensity, but wouldn't harm the athlete or getting a re-injury happen. So it's a very, very safe option. In comparison to the height-focused cue, we think using the velocity-based cue is very ideal for assessing an athlete's ability to generate the force very quickly. But please bear in mind, using this cue will definitely increasing the testing velocity and testing intensity as well. So maybe it's not very favorable utilized when during the initial stages of after the injury or the rehab, because athletes under this condition tend to minimize their joint movement, particularly at the knee and hips, and they intended to rely more on their ankle joints. This will result in a very quickly transition from the eccentric braking phase to the concentric propulsive phase of the jump. Essentially, they're trying to bounce off the ground as fast as they can, which is reflected by a really shallower dip and increasing the vertical stiffnesses of the lower limbs. This cue is particularly useful when testing or training quicknesses or the reactive strength, especially in the sports that demanding the rapid rebound jumping or transitioning actions. Okay, turning to the final suggestion, we have the combined cue. First, a mobilist approach, let's say, where the athletes will blend the benefits from both height and velocity-based cues. In this condition, they kind of achieve achieving the reactive strength modified and reactive strength and reactive strength index modified together, indicating optimal balance of the jump height and minimum ground contact time. This skill is kind of very comprehensive, providing a well-rounded assessment of an athlete's explosive power and the reactive strength during the Countermovement Rebound Jump Test. It's particularly useful when you, let's say, when you want to have an evaluation of the athlete's overall explosiveness, which can give you the insight into both their power output and their ability to quick transfer from one jump to the another.
Do you think that this one, the combined condition, will be the most taxing or the most fatiguing for the athletes?
Yeah, indeed. We also would recommend practitioner to progress from the height focused cue towards velocity-based cue and eventually utilizing velocity-based cue. This is also we used in our familiarization trials, trying to teach them, okay, when you aiming for height, you kind of using what kind of strategy, and when you aiming for velocity, you know, okay, you have to utilize the ankle more because you need to be quick. And finally, we ask them to entering, now, this is your task. You need to be quick while you can't lost your jump height. However, we do find if we offering them in the first hand, okay, you need to jump as quick as you can while reaching the maximum jump height they couldn't achieve, especially the more complex nature of this new jump type, I would say, because it's a combination of the countermovement jump plus the jump jump. It's not a single task like the countermovement jump, just a jump type one time. So maybe they need to progressively utilize the different cues to learn to generate optimal performance matrix by different stages rather than using it in the first attempt.
Okay, so are you saying that if you want to use the third condition, if you are interested in a global view of explosiveness of this athlete, you need to teach them how high they are able to jump first, then you teach them how to do it fast, and then you teach them to combine in order to achieve what you want, so being as explosive as possible.
Yeah, exactly. So maybe you can flip around the sequence between the velocity-based cue and the height-focused cue, but as always, to combine the cue definitely need to come in the later stage, I would say. Definitely don't use it before the other two cues because they may not get your point, okay, what is the quick and what is the height? Because, for example, when I do my testing, we use Hawking Dynamics, which can give you the instant data, the athlete's jump. So when they jump for the height, they know, okay, I can jump 41 centimeter for my countermovement jump and 35 for the second jump of the countermovement rebound jump. And then during the combined cue condition, if they didn't reach that level, I would say, have you gave me your hour efforts for the combined cue? That's kind of a coaching clue to try to get something like the minimum threshold inspiration for your athletes. But if you use the combined cue, they gave you something like 35 plus 31 for both jumps. You don't know whether this is their maximum, maybe not. So I know if you're using the separate height and velocity game, the cue can guarantee that, somewhat guarantee. Yeah.
This is an important point. So you need to both teach the athlete, but also check for yourself what is the maximum for this athlete. So they're actually giving you what you want.
Yeah. Also, maybe they don't need to actually using the height or velocity cue as a general testing protocol. They can use it in the familiarization drill or even as a warm-up drill to practice their athletes. Again, the countermovement rebound jump is more complex. They may be needing more time to warm up, to understand what is the key element they need to achieve during the testing drills.
Good points. Two short questions to finish. The first one is, what is your favorite color?
Would be navy blue.
Navy blue. All right. And the last question, where people can find you if they want to follow your work, see how you're going with your research, or ask you a question?
I think the best platform would be Twitter or currently X. And my ID would be JIAQING_XU96 or Jason XU. You can find me on Twitter.
Thank you so much, Jason.
Thank you very much. Thank you for inviting me, Alex. Thank you.